Hello friends, this is Sushant Kumar and today we are gonna see one of the most important topic of C language, also for C++, void star. In this tutorial series, after understanding the concept of void star, we'll implement generic swap function and generic quick short function of C standard library, okay, which can handle any type of data. I hope after watching this video carefully, you will handle void star easily and you'll have no problem in generic programming. Okay, before going through, let's see some important facts of manipulation of data into memory. Okay, so let's see, friends. For a moment, I'll request you to forget about all the things that you have learned about char, like char stores, char hold characters, char int data types hold integers, double data types, and float data types hold floating points values. Let's forget this. Just focus on this thing that char is of 1 byte of memory, int is of 4 byte of memory, okay, and double is of 8 byte of memory on a 64 bit of operating system, okay, and a pointer to something is also represent 8 bytes of memory, okay. Now what happens when we declare any data, any variable of any of a particular data type, what compiler does and what operating system responds in that syntax, in that code. So let's see, when we declare int or char or something, some data type, compiler sends request to memory manager to reserve fixed amount of memory in RAM. Example, if we give int I or char ch, here for int I, compiler asks to reserve 4 bytes of memory in RAM which have name I. Similarly, for char ch, compiler asks to reserve 1 byte of memory in RAM of name ch. Okay, for int it has name I. So every data has its name, and with that name it has associated a particular memory block. Okay, now see this pictorial view, how really memory or data is manipulated in memory. Okay, so as we know that a RAM is a large chunk of bytes of memory, means a RAM is made up of a large chunk of single bytes of memory, means the smallest memory available in RAM is 1 byte of memory. Okay, so suppose we declare char star ch, a character pointer, or int I, integer, and what happens in memory? Because RAM is made up of RAM is made up of with connected single bytes of memory. So when we declare int, as we know that int is of 4 byte, means 4 byte of single memory will convert it into one block, and that block will be called as a named I, and that block will be what would be interpreted as integer. Okay, similarly, when we declare char star cs, that is a pointer, and it needs 8 byte of memory, means 8 single bytes of memory will form a single block, and that block will be known as a ch, that is a character pointer, and that this pointer will point somewhere, means to a character. Okay, and this 8 byte of memory, these 8 bytes of memory is a single block. Okay, so compiler knows the size of every single data type. Okay, compiler knows that int has 4 byte, compiler knows that character is a 1 byte, compiler knows that pointer to something is of 8 byte, and everything else, double, float, everything else depending on the operating system and the compiler. Now let's see how data is represented. As we all know, computer only understand zeros and ones. Okay, so how data is represented in memory in zeros and ones form. Okay, Suppose we declared char ch equal to a. Now how a would be represented in memory? See, the ASCII value of a is 65, okay, and the binary value of say is a is this 0 1 0 0 0 0 0 1, okay. So this value, this binary value will be, this bit pattern will be copied to a memory block. Suppose the memory address is 100 of ch, and that bit pattern will be copied to, kept copied here, okay. And you can see this bit pattern 0 1 0 0, and this, after interpretation, this will be known as a character a, okay. Similarly, suppose if we give int x equal to 65, then what happens? Because we know that every memory is made up of a single byte of memory. The smallest memory in available we have is 1 byte, okay. So integer is of 4 byte, so integer is made up of 4 single bytes of memory. You can see, if suppose the memory address of integer is 400, then 400, 401, 402, and 403, this whole bytes are now one block, and this one block is an integer block, and this is named as x. And here the data will be, the bit pattern will goes like like this. These three bytes will be 0 because it has 4 bytes. So first byte, that is this byte, will have data, will have the bit pattern 0 1 0 0, and this will be interpreted as 65. This has the integer value 65. The binary value of 65 is this, okay. I hope you are getting my point, what I am trying to say. Now come to how operation on different data types done in memory, okay. Suppose we declare an array of any data type, suppose int array 5, so array of 5 elements, or char ch10 represents array of 10 character elements. Suppose we want to access third element of add, okay, we'll access it with add2. How this line is manipulated? Compiler knows that of data type of add, that is of int, okay. So compiler knows the size of each element, each single element, means the block size, that is of 4 byte, okay. One block size would be a 4 byte. So compiler knows the size, okay, that is each single element contain 4 bytes, okay. So how many bytes? 4 bytes. Now add is the starting address of array, okay. Suppose it's 200, so add2 can be interpreted as starting address of add plus 2 into size of int, okay. Add 2 can be interpreted like this. This is the formula. So behind the scene, under the hood, this thing happens. Compiler changes this syntax of code to add plus 2 into size of int, that is 200 plus 2 into 4, that is 208. So add to the address of position of second, that is sorry, the third element of array add is at 208. So from there data will be taken, data will be accessed, okay. So third element can be accessed from the address 208, okay. Now suppose this is the pictorial view of the same thing which I have told you, how array of 5 elements will be looked, will be, we can see the array of 5 elements in memory as suppose this is a RAM, this is a single short memory of RAM. So 1 2 3 4 5, RAM is made up of single byte of memory, okay. So single byte of memory means 1 2 3 4, 4 byte of memory will form one block, and that one block is int block, okay. And four such block, five such block is needed because we need add of 5 int element, okay. So add 5 of int element means 5 into 4, that is 20 bytes of memory is needed here. Here I have shown that 5 int blocks are reserved by memory manager in the name of air, and the starting address of air is 200, okay, means base address. So this is how memory is interpreted, data is interpreted, or memory is reserved in memory area through memory manager. Okay, now come on the main point, what is void pointer. Friends, please focus on these points, because if you understand if you, these points very clearly, if you focus, then you'll have no problem in future, like in void pointers or in generic programming. Okay, so please listen carefully. A void pointer is a pointer that has no associated data type. As we have seen earlier that every data type has its size, that come through a data type compiler knows how many bytes of memory a single element will take. Okay, you have seen that int has 4 bytes, char takes 1 byte. Okay, so void pointer is that pointer that has no associated data type with it, means it does not know the size, it does not know how many bytes of memory it will take to store a data, to hold a data. Okay, void pointer can hold address of any data type by typecasting. Okay, we'll see how typecasting, through typecasting void pointer can hold address of any data type. Now see malloc and calloc. Okay, malloc and calloc return void star. Okay, that is why, and through typecasting we can typecast that void star to any other data, to any other data type. Okay, how, if we request malloc of 5 elements of int, means int has, compiler knows int has size 4 bytes, and one single byte of memory, that we need 5 of that int, means 5 into 4, that is 20 bytes of memory is needed for 5 int blocks. Okay, so malloc will return a void star, and through typecasting that will be converted into int star. Okay, now void pointer in C are used to implement generic function. Yeah, obviously, uh, in C generic function is done with void star, and will in our next video, in we'll see how generic programming can be done. We'll see example of generic swap function and generic quick short function of C standard library. We'll implement that. Okay. Now void pointers cannot be dereferenced. As you know, how it can dereference, because it does not know how many bytes of memory it has to access. Okay. So it does not know from where to where, how many bytes of memory it has to access. Okay, I hope you're getting my point, what I'm trying to say. Now let's see this thing, this piece of code. Int a equals to 10, void star ptr equal to ampersand a, printf percent d star ptr. What this is saying, so this will give a compile time error. Why? Because we are dereferencing a void pointer, and void pointer does not know how many bytes of memory it has to access to give the data. Okay, and we are, but if we typecast this, that is print a percent d star int star ptr, now it has a knowledge that it has to access 4 bytes of memory. Okay, it has to access 4 bytes of memory. Friends, listen carefully. Every data type, for compiler, every data type is shows that that data type needs some bytes of memory. Like char shows that it needs 1 byte of memory. Similarly, int 4 bytes of memory. Similarly, for double, it needs 8 bytes of memory. Okay, so compiler knows through their names that this data type needs some such bytes of memory. Okay, but for void star, for void, compiler doesn't know. Okay, now see how this, suppose we declare a void star pt. Okay, now void star pt, it has a base address, that is suppose 200. Now it is pointing to something, and it doesn't know how many bytes of memory, and how many bytes of memory a single block will contain, either whether 4 byte or 1 byte. It is a pointer to int, a pointer to char, a pointer to float, a pointer to double, it doesn't know. So it is pointing to something. and that is of base address, suppose here 200. So it does not know the size of one single memory element, one single memory block. Okay, if we typecast this to like char star pt1 equal to char star pt, now this here it does know the size of one memory block. How? char star char star means it is a pointer to character, and character needs 1 byte of memory. So it does know now how many bytes of memory it has to need how many bytes of memory it pointing to. So if cars are pt1, now cars are pt, so now 200, here it can be accessed. Now this can be accessed through data. The data can be accessed now because through typecasting. Here, suppose void star, suppose this void star, we have seen here example, like this example, that if we want to if we want to access a void type of data, and suppose air would have a return type air, means int, instead of int it would have void, then air plus 2 into size of void, and size of void is nothing, so it cannot be dereferenced. Okay, through typecasting we can dereference, we can give data, we can dereference the data, dereference the void star. Okay, friends, I hope you like my video. I hope you understood what I tried to say and what I discuss here, and I hope you'll get more and more deep knowledge of void star. If you want more deep knowledge of void star and generic programming, please follow my next tutorial, that is of swap, generic swap function and generic quickshot. And if you like my video, please subscribe my channel and please comment if you want me to make any other video tutorial on any particular topic of computer science related. Okay, thanks for watching.